Okay, now continuing with subnetting the /24 network. Very easy. Learn to understand there is something to do with borrowed bits. You borrow bits from the host portion, right? You borrow bits from the host portion. The number of bits that you borrow determines the number of subnets that you can create. The number of bits that you borrow determines the number of networks that you can create. So if you borrow 1 bit, you get 2 to the power of n number of subnets. If you borrow 1 bit, you get 2 subnets that you can create. If you borrow 3, 2 to the power of 3, 8. So when you are planning, when you are designing your network, these are the things that an engineer or an administrator needs to take note of. How many networks do I want to create? How many host addresses do I want to have? So that gives us 2 specific ways of determining how to do your design. You either come from how many networks do I want, or how many host addresses do I want. If you say I want 8 networks, if that is your starting point, then it will mean you need to borrow 3 bits from the original network that you get from your ISP. You get 3 bits, then you do your subnetting. If you are using a /24, it means all the 8 networks that you create each will have 30 addresses. If you increase the number of subnets that you create, the number of host addresses decreases. So as the number of subnets increases, the number of hosts will decrease. As an administrator, as an engineer, you now need to find balance. You now need to find balance. How will I be able to design my network? What do I want more? Do I want the number of addresses more, or do I want the number of subnets more? Let's move quickly so that we can have practical examples. Subnetting a /16 and a /8 prefix. All right, what do we have here? Okay, so let me move this. Right. The table highlights all the possible scenarios for subnetting a /16. Okay, so what we have here is we have a /16 network. So originally we have a /16 network and we want to subnet. If we have a /16 network, it means I have 16 bits for the network portion, for the network address. I also have 16 bits for the host portion, starting point. Right. If I want to subnet, I will have to borrow bits from the host portion. So if I borrow 1 bit from the host portion, it will mean I will have a total of 17. On my network side, it will mean I can create 2 subnets, each subnet with 32,700 addresses. If I borrow 2, originally I have 16, I borrow 2, I now have a /18. The 2 I have borrowed will create 4 networks, and each will accommodate 16.380 addresses. If you multiply 4 times these numbers, these 2 numbers right here, the numbers in this row here, and the numbers in this row, they should give you 65,000 or a number close to 65,000, because that's the total maximum number of addresses that you can accommodate with a /16. Originally, you had a /16. A /16 accommodates 65,000 addresses. So even if you break it down, all the addresses, the number of host addresses that you get after breaking down, it should sum up to 65,000. So this is an example of subnetting a network. So if I borrow 1, I get a /17, /18, 2, 3, 4, up until you can borrow up to 15, 16. You cannot borrow 16. If you borrow 16 bits from the host portion, you are left with no bits to use for your host. So you can borrow up to 14. You can borrow 14 bits, and if you borrow 14 bits, you get a /30. How many networks do you create? You create 16,000 networks, but the drawback is each network will now have only two devices in the network, which doesn't make sense. So that's why I said it might make sense if your network, you want every network of the 16,000 networks to have two addresses. But on paper, it's not making sure then. So that's why I was saying you need to find a compromise on the number of networks that you want to create and the number of host addresses that you want to have. Right, more practical example there. Create 100 subnets with a /16. So you are being tasked. Administrator, engineer, you are given this network address from the service provider. 172.16.00/16, right? And you are tasked to create 100 subnets. So your task is to create 100 networks. Subnets, networks, same thing. So I want to create 100 subnets. How many bits will I have to borrow so that I create 100 subnets? I can do simple math. 2 to the power of n is equals to 100. What is my n? I think my n is probably, if I say 2 to the power of 5, 32, 2 to the power of 6, let me see what becomes my n. Okay, let me just use, the answer is right there. Let me not calculate. The answer is right there. 2 to the power of 7. So if I use 2 to the power of 6, it's a number less than 100. I think, let me do quick calculation. 2 to the power of 6, 64. All right. So if I use 2 to the power of 6, I create 64, which is less than 100. So the next best thing is 2 to the power of 7. With 2 to the power of 7, I create 128. From the 128, I can use my 100 and I'm left with 8 subnets. I'm satisfied. So to create 100 subnets, I need to borrow 7 bits. There is no 6.5 bits. That's why we're borrowing 7. If I borrow 7 bits, what does that mean? It will mean I'll change my network from a /16 to a /23. Is it 23? 16 plus 7, it should be 23. From a /16 to a /23. My network, my new network will become a /23, meaning I've borrowed 7 bits from the host portion, right? Since I've borrowed 7 bits, how many bits are left? I have 9 bits left. Let me use this illustration. It will make probably explaining much easier, right? My n. This is my network originally, 16 n's, and I have 16 h for the host, right? If I now borrow 7, it will mean I'll borrow, this one becomes an n, 2, 3, 4, 5, 6, 7. This all becomes the network side. It will now mean I'm left with 9 bits for the host. If I'm left with 9 bits for the host, 2 to the power of 9 minus 2, it gives us what number? Let me see. 2 to the power of 9 minus 2. 510. It gives me a total of 510 host addresses. So in summary, if I borrow 7 bits, I will have a /23 as my new prefix length. I would have created 128 subnets. Each subnet will have 510 host addresses. So basically, that is how you subnet your network. That is how you subnet your network. So in this example, right, in this example, to summarize, we were tasked to create 100 subnets. So our 100 subnets, let me have this. 172.16. What was this? 16.00. 172. Let me illustrate this much clearer here. /16. Right. This was our original IP address. We said we borrowed 7 to create 128 subnets. After we create the 128, that's where we get our 100. After borrowing 7, we are left with 9, which creates 512 host addresses. The range of addresses that we are going to have, let's go a bit deeper. The range of addresses and the networks that we are going to have. Let's have a network site. Let's have the first address. I'll create the last address after this one. Right, the network. The first network that we are going to have is going to be 172.16.0.0. Instead of /16, it's now a /23. That's the first network that we're going to have. The first address, 172.16.0.1. Because remember, the host site, if we had 9 bits, so it's 1, 2, 3, 4, 5, 6, 7, 8. Originally, it's like this. Then the first bit that changes is this one. That gives us the first address, which is .1. Right. The last address that we are going to get, I'll come and create my second network here, my second network ID. Then we get to the last address. Right. Originally, we had 172.16.0.0. I can do this. 16, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? Originally, I had 16. Then I borrowed 7. 1, 2, 3, 4, 5, 6, 7. So this is what I borrowed here. And this became my network. And this is my host. So on the network side, the first network that I will have, it will have 172.16.0.0 because I have 172.16 here and a 0 here and a 0 there. The second network that I will have, what changes? This bit right here changes. This bit here. If that bit changes, this becomes 172.16. And what is this number here in decimal? That number is 2, not 1. 2, and that number is 0. So my second network here is 172.16.2.0/23. All my networks are /23. What becomes my second network? My second network is when probably this one changes. That's the problem of using that screen. Okay. 172.16. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. So this was my This was my boundary. So I was saying the first network address, it's 172.16. Very important to get this. Where the network addresses are coming from, 16.0.0. This is the first network address. The second one, it comes when this bit changes to 1. 1, 2, 3, 4, 5, 6, 7, 8. And what is this number in binary? That number is 2. 172.16.2.0. The third network comes when 0, 0, 0, 0. After 2, obviously, we have 3. So we now have 1, 1. That becomes 172.16.3.0. And it continues up until we have 1, 1, 1, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7. And my demarcation and a 0 there. And when we have all these ones, is 255. So my last network will be 172.16. It should be 255.0. These are my networks. So where the numbers are coming from, they're coming from you understanding how do you manipulate these bits so that you get these networks. Gets easier as we go to other examples. This was subnetting a /100. Let us look at subnetting. Create 1000 subnets with a /8. That's another example. How easy is that? Very easy. So we have a 10, 0, 0, 0 /8. I want to create 1000 subnets. 2 to the power of n is equals to 1000. How many bits do I need to create 1000? 2 to the power of n is equals to 1000. Let me just copy the answer that is there. And let me see. I will need 24 bits. 256. Let me see. 24 host bits. How many bits will I need? 10 bits. 2 to the power of 10. Okay. 10 bits. Right. So I have 10, 0, 0 /8. I want to create 1000 subnets. To create 1000 subnets, I need 2 to the power of n be equal to 1000. And 2 to the power of 10 is equals to, right, 2 to the power of 10 is equals to 1024, which is very close to 1000. So it means I'll need to borrow 10 bits. Initially, I had my network at 10.0.0.0/8. If I borrow 10 bits, it will mean my network will go from there to 10.0.0.18 because I've borrowed 10 bits. How many addresses will each of the networks that I create have? So I'm going to create 1024 networks, each with 2 to the power of n minus 2. The number of bits that are left, I had 8. I borrowed 10. 8 plus 10, 18. 18 minus 32. It means I'm left with 14 bits. I'm left with 14 bits for the host. 2 to the power of 14 minus 2. Let me see. 2 to the power of 14 equals each with 16,382 addresses. Done. So this is your starting point. Instead of having one network with a /8, I'm going to use a /16. If I use a /16, it means I create 1000 networks, and each network we have 16,000 hosts. Is it the same thing that we have here? I think so. Here, they borrowed, how many bits did they borrow? They borrowed 10, yes. So if they borrow 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that is what they borrowed. This becomes the new network portion. Network, and that becomes our new host. Basically, that is what they were doing there. The subnet to meet requirements. Right. Subnet private versus public IP address. All right. When I introduced the types of addresses, I think I talked a lot about the difference between the private addresses and the public addresses. Now, enterprise networks, we have an intranet. This is an internal network, which is supposed to be given private addresses. Also, enterprises will have what we call a demilitarized zone, a DMZ. In the diagram there, you can see this is our private network and this is our DMZ. And what is our DMZ? A DMZ is basically a network where we have servers which face the public. which faces the internet basically. And since they are facing the internet, they're exposed to the internet, they will need to use public addresses, right? In a small network, you don't have a DMZ. It means you only have an internal network. You only need to be worried about private IP addresses. In an enterprise network, larger organizations, they have this. You don't only need your private network. You also need your public IP addresses so that they are used for your DMZ. Now it's very important as an administrator to understand that because it helps you when you create your networks. You know, I'll need to have private public IP addresses and also public IP addresses that are going to be used for my DMZ. The company could use a 10/8 in subnet /16. Okay, that is what we've been doing, creating multiple networks, subnetting networks. So from the networks that you are given, you subnet, and one of the networks you give it to the DMZ basically. The DMZ devices would have to be configured with public IP addresses. Very important, demilitarized zone, it has public IP addresses. This internal network, it has private. The DMZ, it has public. Two different types of addresses. There are two considerations when planning subnets. We discussed this, the number of hosts or the number of subnets needed. So here you can see we have a /24 subnets. This is originally /24 network, and these are the subnets that you get. You borrow one, you get a /25. You borrow 6, you get a /30. These are the number of subnets that you create, and these are the number of hosts that each subnet will have. When you are planning, it's either you consider how many hosts do I want. So if I want 50 hosts, for example, it will mean I'll have to create 4 subnets, each with 62. And from those 4 subnets, I take whatever subnets that I need, and I give my 50 host addresses. If I want to create a network with 10 host addresses, I don't use this one with 60. I go down, I go here. I take that network, which will mean I'll create 16 subnets. I can create, probably I'll need only 8, but I can create all those 16. I use the 8 I want, and I leave the other 8 for future use, for scalability, for example. If the network grows, I can use the other 8 for that. So planning your network, you either consider how many subnets will I need, then how many hosts will I need. We'll probably get more examples as we go. Efficient IPv4 subnetting. This is an example of a headquarter. So here, this is a more practical example. What we have here, we have a network. It has a /22, right? In this example, corporate headquarters has been allocated a public network address. This is not a public IP address, by the way. This is a private. Okay, let's assume it's public. 172.16 is not a public IP. If you remember, private address is 10.0.172. Then we have 192. These are all private IP addresses. So once you see 172 and they're saying public, probably there's an error somewhere. But let's assume this is a public, right? But it's ISP providing 1,000 host addresses. Okay. There are 5 sites and therefore 5 internet connections, which means the organization requires 10 subnets, with the largest subnet requiring 40 addresses. It is allocated 10 subnets with a /26. All right. I'm going to disregard what I'm reading here. A lot of errors. Number 1, this is not a public IP address already. Let me put it this way. I've been given a network 172.16 0, 0. Is it 0, 0? Right, slash 22. 172.16.0.0/22. I've been given that network, and I've been told we want to create 10 subnets. The company has 5 networks. I've been told to create 5 subnets. Let's start with the simple thing. The company, it has 5 networks or sites. So I'm going to create 5 subnets for those 5 networks. That's the easiest thing to start with. I'm going to create 5 subnets. If I want to create 5 subnets, 2 to the power of n is equals to 5. It will mean I'll need 3 bits. Right? I'll need 3 bits to create a maximum of 8 subnets, 2 to the power of 3. From the 8, that's where I'll get my 5. Right? So if I borrow 3 bits, what happens to my network? My network will now change to 172.16.0.0/25 because I've borrowed 3 bits. And the 5 networks that I'm going to create will be 172.16, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I was at 22. So this is 8, 8, 16, 17, 18, 19, 20, 21, 22. Originally, I was here. Then I borrowed 3 bits, which means I'm now right here. This is my network portion. This is my host portion. So when I start changing the bits from the network portion to see what my network addresses become, the first bit that changes is this one. If this one changes to 1, right? If this one changes to 1, it means I'll have a 172.16.0.1/25. That becomes this is my network number 1, this is my network number 2. What will be my network number 3? My network number 3, this one will change to become 1. 172.16.1. This becomes 0. We start with 0/25. Then after that, 172.16.1.1. This becomes a 1. That becomes my 4th network. I want to create a 5th network. 172.16. Now I have a 0 here. I have a 0 here. I have a 1 here. That's a 2.0/25. 5 networks. 3, 4, 5. This is how I create 5 networks from the requirements that I have. The problem with this, I've created 5 networks. Yes, all is well. But how many host addresses are in each network? How many host addresses are in each network, right? Initially, I had 22 bits for the network. I borrowed 3, making a total of 25. 32 minus 25, that's 7. It means I have 7 bits left for host addressing. 2 to the power 7 minus 2. What do we get? Let me see. 2 to the power 7. 128 minus 2, 126. So it will mean each network is going to have 126 host addresses. 126. Keep that in mind. If I then come back here to my 5 networks, this one, it only needs 40. This one, 25. However, I've created 126 here, 126 here, 126 here, 126 here, 126 as well here. 5 networks. However, in this one, I only need 40. 126 minus 40, that's probably 80 plus. 80 plus addresses that are being wasted. 126 minus 25, 100 addresses wasted. 126 minus 15, 110 addresses wasted, etc., etc., etc. That's the problem. When you create from, what are the number of subnets that I need? That's a problem because you waste a lot of addresses. If, however, we had created from how many host addresses do I need? And I say I need 40. 40, 2 to the power of n minus 2 is equals to 40. It will mean how many bits do I need for the host? Not to borrow, how many do I need for the host? 2 to the power 5, 2 to the power 6. It's probably 6. Let me see, 2 to the power 6. Right, 64. 2 to the power 6, 64 minus 2, 62. So if I use 6 bits, for the host, it will mean I'll create networks with 64, 64, 64, 64, 64, instead of creating networks with 128, which makes sense at this stage. However, you see as well, addresses are being wasted here. Addresses are being wasted here. Addresses are being wasted here. But it's much better than when we had 126 or 128. That's why after this, we are going to discuss what we call variable length subnetting after this session. All right. So when we talk of efficient IPv4 addressing, it comes with the planning. If you come from, I want 5 subnets. Yes, you create 5 subnets, you create your networks, but each subnet is going to have 128. That's a problem. You waste addresses. That is not efficient subnetting. If you create from host side and you say, I want 64 addresses, it will mean you are going to use 6 bits from the host. It saves a couple of addresses, much better than 128. It's a better, efficient way. However, it's not the most efficient. The most efficient is to say, here, for 40 addresses, how many bits do I need? I need 4, so I'm going to create, I need 6, so I'm going to create 64. For 25, if I want 25, how many do I need? You see you need 5 bits. And with 5 bits, you create a maximum of 32. For 15 addresses, how many do I need? It's probably the same 5 bits. You create 32 here. For 10, you see you need only 16, 4 bits. 2 to the power of 4, 16. Here for 30, 2 to the power of 5, 32. So with different subnet mask, if I create addresses which are host addresses with 32, it means I've used 5 bits. Here I've used 6 bits. Here I've used 5. Here I've used 4. Here I've used 5 as well. That's where the variable length subnetting mask comes from. And I think we'll get there after this session. VLSM. 5 minutes left. Let me see if I can explain VLSM in 5 minutes. Given the topology, 7 subnets are required. 4 lines and 3 WAN links, and the largest host is building D with 28. A /7 will provide 8 subnets, /27 will provide 8 subnets of 30 host IP addresses, and therefore support this topology. All right, we have a network example there that we are given. Right, it's 192. The network is 192.168.20.0. Okay, 27. That's the network that we're given. And we're asked to create 7 subnets. Okay. Right, our subnets were created already. Sorry. In this example, subnets have been created already. You can see there's a subnet here, 20.0.32.64.96. These are 4 subnets created already, plus 3 for the WAN links. Here, 1, 2, 3. All of them, they have a slash 27, slash 27, slash 27. Right. A slash 27. What does it mean if you have a slash 27? It means you have 5 bits left for the host portion, right? 5 bits left for the host portion, that is 30 max addresses. 30 addresses that you can create. That's where this number is coming from, right? So from those 30, here you have 30, here 30, 30, 30, 30, 30, 30. That's how you've created your subnets. Problem is, like I said before, for this one, you have wasted 5, 10, 15, 2. These numbers are reasonable. But for these one links, instead of having only 2 addresses, you've wasted 28, 28, 28. And if you understand these addresses, you have to pay for them. When you pay to your service provider, you are paying because you are using these addresses. So when you waste, when they are being wasted, that's a problem. I think that is what is being demonstrated here. So once we've demonstrated this wasting of addresses with the subnetting we've learned so far, that means we need a different way of subnetting. And what is that different way of subnetting? That different way of subnetting is variable length subnetting mask. A continuation of what we're explaining. However, the point-to-point one links only require 2 addresses and therefore 28 addresses, making a total of 84 unused addresses. That's the waste. That is where wastage is coming from. Applying the traditional subnetting scheme to this scenario is not very efficient and is wasteful. VLSM was developed to avoid wasting addresses by enabling us to subnet a subnet. Right. The traditional way of subnetting, we had a fixed subnet mask. The length, slash 27, slash 27, slash 27. It is fixed. The new way of doing things, it is variable. When it becomes variable, it means when we do our planning, the host addresses that we assign to a subnet, they should be according to the number of host addresses that are being needed. So for example, if we need two host addresses, 2 to the power of n minus 2 is equal to 2. It will mean we only need to use 2 bits. And if we use 2 bits, suppose we had a slash 24 address, slash 24 subnet, and we've used 2 for the host. It will mean we have 6 left for the network. 24 plus 6 means 30. So it means subnet we were supposed to be using here is a slash 30 instead of a slash 27. A slash 30 here, a slash 30 here. If you look at, lastly, if you look at 15 hosts, 2 to the power of n minus 2 is equals to 15. 17, 2 to the power of n, that's probably a 5, 32. It will mean we have 5 bits that we need for the host. 3 bits left for the network. 24 plus 3 bits is slash 27. So for this one, a slash 27 is proper. For this one, it's proper. For this one, it's proper. For this one, it's proper as well. But for these ones, slash 27, not proper. So that's where variable length subnetting comes in. So in the next session, I'm going to continue with variable length subnetting mask. For now, let's call it a session. We're good. All right.